All right, welcome to lesson 3.2. We are today going to talk about verifying inverses of functions. Yesterday we found inverses, today we're going to verify. Right quick, let's find the inverses of these first two guys. So remember we write it as y equals, and then switch x and y, and then we solve for y. X plus 6 equals 3y. I can either divide by 3 or multiply times 1/3. So when I multiply times 1/3 and then distribute, I get f inverse equals 1/3 x plus 2. Over here, I write it as y equals, switch x and y. Okay, and then I subtract 3. X minus 3 equals 1/4 y. The opposite of 1/4 is multiplying times 4. So my g inverse of x equals 4x minus 12. Okay? Now let's see what happens when we plug the inverse back into the original function. All right, so what I'm going to do is I'm going to take this inverse function and I'm going to plug it in here for my x. All right? We know that if I did something like f of 2, that would mean 3 times 2 minus 6, right? Well, instead, I'm going to do f of the new function, 1/3 x plus 2. So whatever's in the box goes in the box. So this is going to be 3 times what I'm doing f of, 1/3 x plus 2. And then it's minus 6. So this is 3. This is like saying 3x minus 6. Okay? That's the function rule. Okay? So let's simplify this. 3 times 1/3 is just 1, so I don't have to write that. 3 times 2 is 6 plus 6 minus 6. And that part subtracts away. So I'm left with x. Interesting. What happens when I do it the second time? All right, so I'm going to do g of 4x minus 12. So this is 1/4 times 4x minus 12 plus 3. So there we go. 1/4 times 4 is 1. So that's just x. 1/4 of 12 is 3. So minus 3 plus 3. This also gives me x. So what happens? You just get x. All right, so we can algebraically verify, this is going to happen every time, if you plug the inverse into the original function, and it simplifies to y equals x. All right, so this is y equals x. Y equals x. All right, so I know it's inverse if I can plug it back in and it gives me y equals x. Let's test it out. All right, so you can also sometimes see h of k of x. You might see it written like that. So this is equal to h, the h rule is 2/3 times k of x, which is 3/2 x minus 9, and then minus 6. So 2/3 times 3/2, that gives me 1. 2/3 of 9 is 6, but it's negative, minus 6 minus 6. So that gives me x minus 12. So nope, doesn't work. How about for the next one over here? We're going to do m of n of x. So this is minus 4 times negative 1/4 x plus 5/4 plus 5. So minus 4 times negative 1/4 gives me 1, so this is x. And recall that minus 4 times 5/4 is the same thing as minus 4/1 times 5/4. And the easiest way to do that is to see that the 4's cancel, and this just gives me minus 5. So this is x minus 5 plus 5. Those cancel out, so this gives me x, and yes, those are inverses. Right? Pause if you need to and review any of that stuff, but we march on. All right, how can we tell if they're graphically inversed? If y equals x is a line of reflection. Or are the x's and y's swapped? Okay, so looking at the first one, if I draw in y equals x, that is this perfect diagonal here. And I can see, number one, that the lines cross at y equals x, and then everything is a reflection directly across. Okay, so let's get those out of the way because they're ugly. So yes, this one works. Okay, for the other one, also, if I look at points, okay, so this point right here is 0, 3. This point right here is 3, 0. I've got negative 4, 4 right here, and I've got 4, negative 4 right here. So those points are reflections. Okay. Again, on the second one, if I'm over here and I draw in y equals x, looks something like that. They do all cross at y equals x, but these are not reflected, okay? Easy enough to see that this one doesn't work. Also, if I consider points, I've got 9, 0, but 0, 9 is nothing. I've got 5, 2, but 2, 5 is not there. So this one's definitely not reflected. All right, moving on. We can look at the data in tables. How can we tell? All right, if the domain of one becomes the range of the other. All right, so I'm looking for 12, negative 5. Does it exist? Yes, it exists down here. It's not straight across. That doesn't work, but it does happen there. And then 7, negative 2 is right here. And 2, 1 is right here. And then 4, negative 3, negative 3, 4 is there and there. So this one does the same data. It's inverse and it's going up. But remember, as long as the domain of C of x is the range of D of x, then we're good. And that is the case. Doesn't matter how the data appears. However, we may get it to where the data is not so neat and tidy. All right, so when I look at this guy, this domain and this range are not the same set of numbers, okay? But we're going from dollars to euros and euros to dollars, so we would think that it should work. So what we're going to have to do here is use our linear regression tools from the first unit. All right, and remember, we can do that on Desmos or we can do it in our calculator, okay? So if I were to look in the calculator, I'm going to do stat edit, stat calc. So let's move over to our calculator, switching apps, and where is it? There it is. So I'm going to go stat edit, and I need the data in euros. So it's 8.78 and 17.56 and 26.34 and 35.12 and 43.90. And then I go stat calc option 4 and hit all the enters, and stat calc one. Oh, I'm doing the wrong thing there. Sorry. I'm confusing you. I want to do option 4, and there we go. That is giving me wrong information. I'm not sure what's happening, so don't run with that yet. Stat edit. We've got, I didn't change this last data. This one should be 43.9. All right, now stat calc, option 4, enter. There we go. So 0.878. That minus 7 times 10 to the negative 15th is essentially 0. So here we can write y equals 0.878x. Okay? And then for euros to dollars, we've got the same x values, but different y's. So 11.39 and 22.78 and 34.17 and 45.56 and 56.95. So stat calc option 4, enter, and I get 1.139, and again plus 0. So y equals 1.139x. Okay, so now we do the same thing that we were doing before algebraically. Okay, we're going to evaluate y equals 0.878 times 1.139x. And when I multiply those out, 0.878 times 1.139, I get, well, I did a negative, but it's 1.00000. All right? So this is y equals x. So yes, these are inverses. Okay? So we've got some tables here. Again, you can do linear regression to figure out what the function is. This one is y equals 1/2 x minus 3. The second one is y equals 2x minus 3. You can do linear regression and figure that out. You don't need me to show you that. So now if we test to see if these two work, I would say y equals 1/2 times 2x minus 3 minus 3. And the 1/2 minus times 2 works out, so that gives me x minus 1/2. Sorry, this one is plus 3. This should be a plus. So x plus 1/2 minus 3, but that part doesn't work, so this is not inverses. All right. How about the second set? This goes up 6/2. So this is y equals 3x minus 5. And this one is y equals 5/3. Nope, it's not. It's 1/3. Sorry. 1/3 x plus 5/3. So are they inverses? Y equals 3 times 1/3 x plus 5/3 minus 5. 3 times 1/3 gives me just x. 3 times 5/3, the 3's cancel. Plus 5 minus 5. So yes, it works. All right? So when you're given the data in the table, do linear regression, figure out what the equation is, plug the inverse into the original equation, and Bob's your uncle. I hope you enjoyed the notes for today. I hope some of you watch it. And until next time, if you're watching these in real time, know that we will have a quiz over 3.1 and 3.2 on Tuesday or Wednesday. That's the next day in class. In 2023, that's October 31st and November 1st. If I use these videos again in the future, those dates may change. And then the test is coming at the end of next week as well in 2023. Happy mathing, and we'll see you next time.